Overview of logical volume management. Logical volume manager LVM creates a layer of abstraction over physical storage, which helps you to create logical storage volumes. This offers more flexibility compared to direct physical storage usage. In addition, the hardware storage configuration is hidden from the software, so you can resize and move it without stopping applications or unmounting file systems. This can reduce operational costs. LVM architecture. The following are the components of LVM physical volume. A physical volume PV is a partition or whole disk designated for LVM use. For more information, see Managing LVM physical volumes. Volume group. A volume group VG is a collection of physical volumes which creates a pool of disk space out of which you can allocate logical volumes. For more information, see Managing LVM volume groups. Logical volume. A logical volume represents a usable storage device. For more information, see Basic Logical Volume Management and Advanced Logical Volume Management. The following diagram illustrates the components of LVM. LVM logical volume components. Logical volume 1, logical volume 2, logical volume n. First it's RCR physical volume 1, physical volume 2, physical volume n. And volume group, it combination of physical volumes creates a volume group and volume group. So it is all the physical volumes combined into one is a volume group. And these are logical volumes, logical volume 1, logical volume 2, logical volume n. Advantages of LVM. Logical volumes provide the following over advantages over using physical storage directly. Flexible capacity. When using logical volumes, you can aggregate devices and partitions into a single logical volume. With this functionality, file systems can extend across multiple devices as though they were a single large one. Convenient device naming. Logical storage volumes can be managed with user-friendly defined and custom names. Resizable storage volumes. You can extend logic volumes or reduce logical volumes in size with simple software commands without reformatting and repartitioning the underlying devices. For more information, see resizing logical volumes. Online data relocation. To deploy newer, faster, or more resilient storage subsystems, you can move data while your system is active using the pvmove command. Data can be rearranged on disk while the disks are in use. For example, you can empty a hot swappable disk before removing it. For more information on how to migrate the data, see the pvmove man page and removing physical volumes from a volume group. Striped volumes. You can create a logical volume that stripes data across two or more devices. This can dramatically increase throughput. For more information, see creating a striped logical volume. RAID volumes. Logical volumes provide a convenient way to configure RAID for your data. This provides protection against device failure and improves performance. For more information, see configuring RAID logical volumes. Volume snapshots. You can take snapshots, which is a point-in-time copy of logical volumes. Logical volumes for consistent backups or to test the effect of changes without affecting the real data. To test the effect of changes without affecting the real data. For more information, see Managing logical volume snapshots. Thin volumes. Logical volumes can be thin provisioned. This allows you to create logical volumes that are larger than the available physical space. For more information, see creating a thin logical volume. Caching uses fast devices like SSDs to cache data from logical volumes, boosting performance. For more information, see caching logical volumes. Thin volumes caching uses fast devices like SSDs to cache data from logical volumes, boosting performance. For more information, see caching logical volumes. Additional resources customizing the LVM report. Additional resources customizing the LVM report. Managing LVM physical volumes. A physical volume PV is a physical storage or a partition on a storage device that LVM uses. During the initialization process, an LVM disk label and metadata are written to the device. LVM disk label and metadata are written to the device, which allows LVM to track and manage it as part of the logical volume management scheme. Notice you cannot increase the size of the metadata after the initialization. If you need larger metadata, you must set the appropriate size during the initialization process. You cannot increase the size of the metadata after the initialization. If you need larger metadata, you must set the appropriate size during the initialization process. When initialization process is complete, you can allocate the PV to a volume group. You can divide this VG into logical volumes, which are the virtual block devices that operating systems and applications can use for storage. To ensure optimal performance, partition the whole disk as a single PV for LVM use. Creating an LVM physical volume. You can use the pvcreate command to initialize a physical volume LVM usage. Creating an LVM physical volume. You can use the pvcreate command to initialize a physical volume LVM usage. Prerequisites: administrative access. The LVM 2 package is installed. Procedure: identify the storage device you want to use as a physical volume. To list all available storage devices, use lsplk. Identify the storage device you want to use as a physical volume. To list all available storage devices, use lsplk. Identify the storage device you want to use as a physical volume. To list all available storage devices, use lsplk. lsblk. So I have STB and STC, which I can use for the for this particular volume management, that is LVM, for the creation of volume group, physical volumes, volume group, and logical volumes. lsblk command. So this command will list all the devices STA, STB, STC. I've added two new devices, STB and STC. STD I've already used for SCSI actually. I've already used this for the SCSI practicals. So create an LVM physical volume pv create slash save slash STB. Create an LVM physical volume pv create slash save slash STB. Replace slash save slash STB with the name of the device you want to initialize as a physical volume. pv create slash save slash stb pv create slash save slash stc. Okay, so stb is in use, so I'm using stc. So I created successfully created physical volume slash save slash stc successfully created, creating devices file slash etc slash lvm slash devices slash system dot devices. Replace slash name slash st with the name of the device you want to initialize as a physical volume. Verification steps. Display the created physical volume PVS. So to create display the created physical volume, I will use the command PVS slash name slash stc is the physical volume, volume group, FMT, LVM2, ATTR. P size means physical extent size, pi G, 5.00G. P size 5.00G. Physical extent, the size of the physical extent actually, P size. So slash save slash stb pv vg fmt lvm2 format is lvm2 attr no attributes here, there is an attribute a. P size is 28.87g and p3 is 13.87g. Here the dimensions are different. Additional resources: pv create, pv display, pvs, pv scan, lvm man pages on your system. Resizing physical volumes by using the storage RHL system. With the storage system role, you can resize LVM physical volumes after resizing the underlying or storage or disk from outside of the host. For example, you increase the size of a virtual disk and want to use extra space in an existing LVM. For example, increase the size of a virtual disk and want to use extra space in an existing LVM. Prerequisites: you have prepared the control node and the manage nodes. For example, increase the size of a virtual disk and want to use extra space in an existing LVM. Prerequisites: you have prepared the control node and the managed nodes. You have prepared the control node and the managed nodes. You are logged into the control node as a user who can run playbooks on the managed nodes. The account you use to connect to the managed nodes has sudo permissions on them. The size of the underlying block storage has been changed. Create a playbook file called tilde slash playbook.yml with the following content: triple hyphen space name colon space manage local storage host colon space managed hyphen node hyphen 01 dot example dot com task colon hyphen space name colon resize LVM PV size resize LVM PV size ansible dot built-in dot include underscore role colon name colon red hat dot RHL system roles dot storage RHL system roles dot storage VRS colon storage underscore pools colon hyphen space name colon my VG this colon in square bracket double quote STF type colon LBM grow to fill is equal to true grow to fill colon true. For more details about all variables used in the playbook, see the USR share doc, USR share Ansible roles, RHL system roles dot storage slash readme.md file on the control node. We're going to create this playbook.yml. vi. I'll create a separate directory. Playbook change directory to playbook directory. Here I'm creating a file vi playbook.yml. So this is an Ansible file. So what are the contents of this? Triple hyphen space name colon space manage local storage. Manage local storage. Host colon space manage hyphen node hyphen 01 dot example dot com. Host colon space managed hyphen node hyphen 01 managed hyphen node hyphen 01 manage node 01 dot example dot com managed node 01 dot example dot com tasks. What are the tasks? Hyphen space name colon. What is the name of the task? Resize LVM PV size. Resize LVM PV size. Resize LVM PV size. Ansible built-in include underscore role colon. Ansible built-in include role. Ansible built-in include role colon name colon redhat dot rhel underscore system underscore roles dot storage. Name colon redhat dot rhel system storage roles dot storage. Ansible built-in include role. Ansible built-in include role. What is the name? Name is redhat dot rhel system roles dot storage. Redhat dot rhel system roles dot storage. Redhat rhel system roles dot storage. rhel system roles. Redhat dot rhel system roles dot storage. VRS colon variables. Storage underscore pools colon. Storage underscore pools colon. Hyphen space. Variable storage pools. So name of the storage pool. Name colon myvg. This colon. In square bracket double quote STF This is STF, type is LVM, grow to fill colon true, grow to LVM colon true, grow to fill, variable storage underscore pools colon hyphen space, name colon mybg dis colon STF, type colon LVM grow to fill colon true, STF, grow to fill colon true, save and exit the file, save this file, playbook.yml, validate for more details about all variables used in the playbook. See the USR share Ansible roles RHEL system roles dot RHEL system roles dot storage readme dot cmd file on the control node. Validate the playbook syntax Ansible hyphen playbook hyphen syntax hyphen check tilde slash playbook dot yml Ansible hyphen playbook Ansible hyphen playbook hyphen syntax hyphen check Ansible hyphen playbook Ansible playbook syntax check playbook.yml host list is empty. Only localhost is available. Note that the implicit localhost does not match all. Couldn't resolve module or action Ansible built-in include role. This often indicates misspelling, missing collection or incorrect module path. Ansible built-in include. The error appears to be in slash root slash playbook.yml line 5 column 7 but may be elsewhere in the file depending on the exact syntax problem. The offending line appears to be task colon hyphen space name colon resize LVM PV size here. So let us look at it one by one. So vi playbook.yml match says all. So host, since this host is not available, I'll give the current server host. server.example.com and Ansible. So it is a dot here, not a underscore, not an underscore. Ansible built-in roles include Ansible.builtin.row include underscore roles. Ansible built-in include underscore role. I will do the syntax check again. Ansible hyphen playbook hyphen syntax check playbook.yml. Provided host list is empty, only local host is available. So I have solved one problem. Playbook dot the Error Ansible module or action not available, problem is resolved. Couldn't match host pattern, ignoring server a.example.com. Host pattern host colon manage node 01.example.com vi triple space name colon local storage host colon. So note that this command only validates syntax and does not protect against a wrong but valid configuration. Run the playbook Ansible playbook.yml. Display the new physical volume size. vi playbook.yml. So here there is another mistake. Ansible it says no matched hosts. Localhost does not match all. So display the new physical volume size. Ansible manage-node manage-node-0.example.com-m command-a in single quote PVS. Removing LVM physical volumes. You can use the pv remove command to remove physical volume for LVM usage. pv remove command to remove physical volume for LVM usage. Prerequisites administrative access. Procedure list the physical volumes to identify the device you want to remove. PVS, type the PVS command. PVS command /save/stc is the physical volume. Remove the physical volume. PV remove /save/stc. PV remove /save/stc. Labels on physical volume /save/stc successfully wiped. Replace /save/stp1 with the name of the device associated with the physical volume. Note if your physical volume is part of the volume group, you need to remove it from the volume group first. If your volume group contains more than more than one physical volume, use the VG reduce command. VG reduce volume group name slash save slash STB1. VG reduce volume group name. VG reduce volume group name slash save slash STB1. Replace volume group name with the name of the volume group. Replace slash save slash STB1 with the name of the device. If your volume group contains only one physical volume, use VG remove command. VG remove volume group name. Replace volume group name with the name of the volume group. Verify the physical volume is removed. So verify the physical volume is removed. PVS. So physical volume is removed. Additional resources. PV remove man page on your system. Creating logical volumes in the web console. Logical volumes act as physical drives. You can use the RHEL and web console to create LVM logical volumes in a volume group. Logical volumes act as physical drives. You can use the RHEL and web console to create LVM logical volumes in a volume group. Prerequisites: you have installed the RHEL and web console. You installed RHEL and web console. You have enabled the cockpit service. You have installed the your user account is allowed to log into the web console. For instructions, see installing and enabling the web console. The cockpit storage package is installed on your system. The volume group is created. Procedure. Chapter 3: Managing LVM volume groups. You can create and use volume groups VGs to manage and resize multiple physical volumes PVs combined into a single storage entity. Extents are the smallest units of space that you can allocate in LVM. Physical extents P and logical extents L has the default size of 4 MIP bytes. Physical extents P and logical extents LE has the default size of 4 MIP that you can configure. All extents have the same size. When you create a logical volume LV within a VG, LVM allocates physical extents on the PVs. The logical extents within the LV correspond one-to-one with physical extents in the VG. You do not need to specify the P's to create LVs. LVM will allocate the available P's and piece them together to create a LV of the requested size. Within a VG, you can create multiple LVs, each acting like a traditional partition but with the ability to span across physical volumes and resize dynamically. VG can manage the allocation of disk space automatically, creating an LVM volume group. You can use the VG command to create a volume group. You can adjust the extent size for very large or very small volumes to optimize performance and storage efficiency. You can specify the extent size when creating a VG. To change the extent size, you must recreate the volume group. Prerequisites: administrative access. The LVM2 package is installed. One or more physical volumes are created. For more information about creating physical volumes, see creating LVM physical volume procedure. List and identify the PV that you want to include in the VG PVS. So first I'll create physical volumes. On SDC and STD. PV create slash save slash SDC and PV create slash save slash STD. So STD is already used actually. So I will use slash save slash STA. So I'm using A and the C. Create a VG. VG create volume group name physical volume 1, physical volume 2. Replace volume group with the name of the volume group that you want to create. Replace physical volume name with the name of the PV. To specify the extent size when creating a VG, use the -s extent size option. Replace extent size with the size of the extent. If you provide no suffix, size suffix, the command defaults to MB. Replace extent size with the size of the extent. If you provide no suffix, size suffix, the command defaults to MB. VG create volume group name. The name of the volume group is vol group 1. I will create vol group 1. Physical volume name 1, physical volume name 2. Slash save slash STA and slash save slash STC. So volume group 1 successfully created. You can use the VGS command to check the volume group. Volume group 1, it has two physical volumes. Size of the volume group is 24. V size is 24G, V freeze is 24G. So it is 24 GB, 25 GB actually, 24.99 GB. So PVS will show the physical volumes. See, these physical volumes STA and STC are part of the volume group 1 and volume group 2. So size of the first physical volume STA is 20 GB, size of second physical volume is 5 GB. Verify that the VG is created using VGS command. VG PV LVSN ITTR V size V free. Additional resources VG create VGS and PVS man pages on the system. Creating so renaming an LVM volume group. You can use the VG rename command to rename a volume group. Prerequisites administrative access. The LVM2 package is installed. One or more physical volumes are created. For more information about creating physical volumes, see creating LVM physical volume. The volume group is created. For more information about creating volume group, see section 3.1 creating an LVM volume group. Procedure list and identify the VG that you want to rename VGS. So suppose I want to rename a volume group, type the VGS command. VGS command will show me the volume groups that I have. I have the volume group V group 1, volume group 1. So to rename the volume group, use the command VG rename, old volume group name, new volume group name. VG rename, VG I will rename it to volume group 100. VG rename volume group 1 to volume group 100. Volume group 1 successfully renamed to volume group 100. Replace old volume group name with the name of the VG. Replace new volume group name with the name of for the VG. Verify that the VGS name VGS. Verify that the VGS name VGS. Additional resources VG rename VGS man pages extending an LVM volume group. You can use the VG extend command to add physical volumes to a volume group. Extending an LVM volume group. Prerequisites. Administrative access. The LVM2 package is installed. One or more physical volumes are created. For more information about creating physical volume, see creating LVM physical volume. The volume group is created. For more information about creating volume group, see section 3.1 creating an LVM volume group. List and identify the VG that you want to extend. So list and identify the VG that you want to extend. Use the VGS command. List and identify the PVs that you want to add to the VG. List and identify the PVs that you want to add to the VG. I will create one more physical volume. For that I will add another disk here. So in the player manage virtual machine settings, add I'm going to add another hard disk here. Add a hard disk, new hard disk, create a new virtual hard disk. Only 2 GB. I will create a 2 GB hard disk. Next, finish. Okay, I need to reboot the system. fdisk-l reboot. List and identify the PVs that you want to add to the VG. PVS. List and identify the VG that you want to extend VGS. List and identify the PV that you want to add to the VG PVS. So rebooted the system. So list and identify the PVs that you want to create to the VG. So VGS command. So VGS command volume group 100. It has two physical volumes PVS. So slash a slash st slash a slash stc fd hyphen L. I've added a new physical volume of 20 GBIB STE slash a slash a slash st 20 GB bytes. So it has become 20 instead of it is slash a slash STD. The names are changing, so it is slash a slash STD here. So I will create a physical volume of slash a slash STD. So STD is being used, then I will create a physical volume on slash a slash STE. So physical volume ST is successfully created. Physical volume ST is successfully created. So accidentally I've given 20 GB, should have given 2 GB. So PVS command. So now I have three physical volumes STA, STC, STE. I will create, sorry, one is not a physical volume. Okay, ST is also in the, ST is a physical volume, but it is not in the volume group. You can see it is not in the volume group. We vol group 100. So add it to the volume group. I use the command VG extend volume group name space physical group physical volume name. VG extend volume group name. Volume group name is VG vol group 100 physical volume slash save slash STE. So volume group vol group 100 successfully extended. You can see VGS. It has now three physical volumes. Size is 45 GB and PVS physical volume. So ST is now part of volume group 100. Replace volume group with the name of the VG. Replace physical volume with the name of the PV. Verify that the VG now includes the name PV, PVS. Additional resources VG extend VGS PVS man pages. Combining LVM volume groups. You can combine two existing volume groups with the VG merge command. The source volume will be merged into the destination volume. Administrative access. You can combine two existing volume groups with the VG merge command. The source volume will be merged into the destination volume. You can combine two existing volume groups with the You can combine two existing volume groups with the VG merge command. VG merge. The source volume will be merged into the destination volume. Prerequisite administrative access. The LVM2 package is installed. One or more physical volumes are created. For more information about creating physical volume, see creating LVM physical volume. Two or more volume group are created. For more information about creating volume group, see section 3.1 creating an LVM volume group. List and identify the VG that you want to merge. List and identify the VG that you want to merge. VGS. So there are two volume groups here, volume group name 1, volume group name 2. Here I will add three new disks of 1 GB each, 1 GB size. Manage virtual machine settings. Add hard disk. SCSI hard disk. Create a new virtual hard disk. Size is 1 GB. The size is 1 GB. I will add two more hard disks here. Add a hard disk, SCSI hard disk. Size is only 1 GB. Store virtual disk as a single file. So reboot the server. SU enter. So fdisk hyphen L. So SDE, SDF, and I will filter it for 1 GB. So this is 1 GB SDE, SDF, and SDD. So fdisk LSBLK. So DEF. So DEF. So DEF. I'll use this DEF to create new volume group. Physical volume first. So PV create /STE STD SDE STD is already being used. So it is changing actually. So I've used E. I will use F. So I'll create it using two physical volumes, VGS, PVS. Now STE and STF have two other extra physical volumes. I'll create a volume group using this VG create vol group 200 /STE /STF. So volume group successfully created. Now I have two volume groups, volume group 100 and volume group 200. PVS will also show me the physical volumes and volume groups that are in the system. List and identify the VG that you want to merge. VGS command. List and identify the VG that you want to merge. VGS command. Merge the source VG into the destination VG. VG merge. Volume group name 2 and volume group name 1. So this is merge the source VG into the destination VG. So replace volume group name 2 with the name of the source VG. Replace volume group name 1 with the name of the destination VG. VG merge. VG merge. So your source VG is vol group 100 and destination VG is vol group 200. Or I think first I have to give 200 source GB and the destination GB. The source is 200, destination is 100. Volume group 100 successfully merged into volume group 200. VGS. So volume group 100 successfully merged into volume group 200. So volume group 100 is I have merged volume group 100 into volume group 200 now, into the new one. Verified that the VG now includes the new PVs. So VGS. So VGS will show me only the volume group 200 and PVS. PVS is also now showing me volume group 200. Removing physical volumes from a volume group. To remove unused physical volumes from a volume group, use the VG-reduce command. The VG-reduce command shrinks a volume group's capacity by removing one or more empty physical volumes. This frees those physical volumes to be used in different volume groups or to be removed from the system. This frees those physical volumes to be used in different volume groups or to be removed from the system. Removing physical volumes from a volume group. To remove unused physical volumes PVs from a volume group VG, use the VG reduce command. The VG reduce command shrinks a volume group's capacity by removing one or more empty physical volumes. This frees those physical volumes to be used in different volume groups or to be removed from the system. Procedure: if the physical volume is still being used, migrate the data to another physical volume from the same volume group. So I will try the command pvmove /save /ste /save ste. No data to move for volume group 200. So there is no data, so it will move this to the volume group 200. So pvmove command moves it to the volume group, moves the data from PV from this physical volume to the volume group in case there is any data on the physical volume. If there are not enough free extents on the other physical volumes in the existing volume group, create a new physical volume from /dev/vdb4 pv create /dev/vdb4 and add the new created physical volume to the volume group. VG extend volume group name /dev/vdb4. Move the data from /dev/vdb3 to /dev/vdb4. So pv move /dev/vdb3 to /dev/vdb4. So here I will try pv move /dev/ste to /dev/stf. There is no data to move actually for the volume group 200. So that's why it's not moving anything. Remove the physical volume /dev/vdb3 from the volume group. Data, After moving the data from the physical volume to another physical volume or to the volume group, to any of the physical volumes in the volume group, you can remove the physical volume from the system. To remove the physical volume, from the volume group. From the volume group, use the command vg reduce volume group name space physical volume. vg reduce volume group name vol group 200 and the name of the physical volume. Say I want to remove the 20 GB disk /save/sth. You cannot remove STH, I can only remove STE because I moved the physical volume from STE to STF. So remove /save/STE, remove from the volume group. Now PVS command. So physical volume /save/STE does not belong to the volume group 200, and VGS command will now show only four physical volumes. See, earlier the size was 46.98 GB, now the size is 45.98 GB. VG reduce volume group /dev/vdb3. Verification: verify that the /dev/vdb3 physical volume is removed from the volume group name volume group. Previous is the physical volume. Previous will display the existing physical volumes. See, VDB3 has been removed from volume group name. So here I have removed ST from the volume group 200, volume group 1, volume group 200. Additional resources VG reduce PV mode PVS man pages on your system, splitting a LVM volume group if there is enough unused space on the physical volumes. If there is enough unused space on the physical volumes, a new volume group can be created without adding new disks. Splitting LVM volume group if there is enough unused space on the physical volumes. A new volume group can be created without adding new disks. In the initial setup, the volume group name one consists of /tab/VDB1 /tab/VDB2 and /tab/VDB3. After completing this procedure, the volume group name one will consist of /tab/VDB1 and /tab/VDB2 and second volume group name 2 will consist of /tab/VDB3. So first volume group right now consists of VDB1, VDB2 and VDB3. After completing this procedure, the volume group name one will consist of /tab/VDB1 and /tab/VDB2 and second volume group name 2 will consist of /tab/VDB3. So splitting in LVM logical volume. Splitting in LVM volume group. Prerequisites: you have sufficient space in the volume group. Use the VG scan command to determine how much free space is currently available in the volume group. Depending on the free capacity in the existing physical volume, move all the used physical extents to other physical volume using the PV move command. Depending on free capacity in the existing physical volume, move all the used physical extents to other physical volume using the PV move command. For more information, see removing physical volumes from a volume group. Split the existing volume group name one to the new volume group name 2. VG split volume group name 1, volume group name 2 /save/VDB3. Split the existing volume group name 1 to the new volume group name 2. So use VG scan first. Found volume group 200 with you using metadata LVM2. Using metadata LVM2, I have already used the PV move command. PV move. If I use only this one physical volume, it will move all the physical extents that is being used by SD. This one SD2. The other physical volumes in the volume group. I have given a specific physical volume. This is a new physical volume. Second one, so I have moved the physical extents from ST to STF, and then I tried to reduce the volume group. I removed the STF physical volume from the volume group. I'm using same thing I need to do PV move, and then first VG scan PV move command, and then use the VG split command. VG split. Suppose I want to remove this one also. Now I want to uh, split F and H. I want to split F and H from the volume group 200. So VG split, okay. VG split volume group name 1. Volume group name 1 is volume group 200. Volume group name 2. Volume group 100. I am having now the name of the physical volume. Physical volume is I will give STF. Because there is no data, I have not used PV move. Otherwise, I need to use PVM and move all the physical exchange from STF into the volume group. So new volume group, VG, volume group 100 successfully created from volume group 200. Use VGS, PVS. So it contains only one. It contains only one. So STF and STH. Sorry, STF and ST. No power here actually. Not able to see the keyboard. So existing volume group 100 successfully split from volume group 200. So VGS command. So now it is showing in volume group 100 I have two physical volumes. In volume group 200 also I have two physical volumes. PVS will show me. So SDA and B belongs to 200 and F and H belong to 100. SDE doesn't belong to any volume group. The volume group SDE does not belong to any volume group. Note if you have created a logical volume using the existing volume group, use the following command to deactivate the logical volume. So if you have created any logical volume using the existing volume group, use the following command to deactivate the logical volume. First deactivate the logical volume. LV change -A -N and name of the logical volume /name volume group name 1 logical volume name. So -A. So I think this will deactivate -A will deactivate the logical volume. Name of the logical volume is /name volume group name 1 logical volume name. View the attributes of the two volume groups using VGS. View the attributes of the two volume groups using VGS command. Verify that the newly created volume group name to consists of /name/VDB3 physical volume. So verify that the newly created volume group name to consists of /name/VDB3 physical volume. Verify that the newly created volume group name to consists of /name/VDB3 physical volume PVS. Additional resources VG split VGS and PVS man pages on your system. Moving a volume group to another system. You can move an entire LVM volume group VG to another system using the following commands. VG export. Use this command on an existing system to make an inactive VG inaccessible to the system. Once the VG is inaccessible, you can detach its physical volumes PV. So first to use this command VG export, use this command on an existing system to make an inactive VG inaccessible. So the VG must be inactive and it must be inaccessible to the system. Then once the VG is inaccessible, you can detach its physical volumes. You can detach its physical volumes and then VG import. So first inactivate the VG. So once VG becomes inaccessible to the system, detach all the physical volumes and then VG import. Use this command on the other system to make the VG which was inactive in the old system accessible in the new system. So VG import, use this command on the other system to make the VG which was inactive in the old system accessible in the new system. Prerequisites: no users are accessing files on the active volumes in the volume group that you are moving. No users are accessing files on the active volumes in the volume group that you are moving. So users are not accessing files on active volumes in the volume group that you are moving. Unmount the logical volume name. Umount /dev/mnt logical volume name. Deactivate all logical volumes in the volume group. So first unmount the logical volumes and then deactivate all logical volumes in the volume group which prevents any further activity on the volume group. VG change. VG change -an volume group name. VG change -an volume group name. VG change volume group in double quote volume group name successfully deactivated. So VG change -an volume group name. So deactivate all logical volumes in the volume group which prevents any further activity in the volume group. Export the volume group to prevent it from being accessed by the system from which you are removing it. Export the volume group to prevent it from being accessed by the system from which you are removing it. Export the volume group to prevent it from being accessed by the system from which you are removing it. VG export volume group name. So VG export -hyphen volume group in bubble quote volume group name successfully exported. So VG change -an volume group name. So volume group successfully deactivated. Before this command, unmount the logical volume and then deactivate the logical volume group using VG change command. Umount VG change and VG export. VG export PV scan. View the exported physical volume group. PV scan. So how to view the exported volume group? Exported volume group using PV scan command. PV scan command will list the exported volume group. So PV scan will scan all the volume groups here. Volume groups, physical volumes and volume groups and everything. View the exported volume group using the PV scan command. Shut down your system and unplug the disk. So it's an exported volume group. Shut down your system and unplug the disk that to make up the volume group and connect them to the new system. So shut down your system and unplug the disks that make up the volume group and connect them to the new system. Plug the new disk into the new system and import the volume group to make it accessible to the new system. VG import volume group name. VG import volume group name. You can use the hyphen force argument of the VG import command to import volume groups that are missing physical volumes and subsequently run the VG reduce remove missing command. VG import volume group name. To make it accessible in the new system, VG import, export import, VG export import, VG change and umount. You can use the hyphen force argument of the VG import command to import volume groups that are missing physical volumes and subsequently run the VG reduce hyphen remove missing command. Activate the volume group VG change -AY volume group name. So AN will deactivate, AY will activate it. AN will deactivate the volume group and AN will deactivate the volume group. AY will activate the volume group. VG import volume group name. Activate the volume group. VG change -AY volume group name. Mount the file system to make it available for users. mkdir-p/mnt/volume group name /users mount /this/ volume group /users on /mnt/volume group name /users. Additional resources. Removing LVM volume groups. VG import, VG export, VG change man pages on your system. Removing LVM volume groups. You can remove an existing volume group using the VG remove command. Existing volume group using the VG remove command. Only volume groups that do not contain logical volumes can be removed. You can remove an existing volume group using the VG remove command. Only volume groups that do not contain logical volumes. So only logic volume groups that do not contain logical volumes can be removed. Prerequisites: administrative access. Procedure: ensure the volume group does not contain logical volumes. Ensure the volume group does not contain logical volumes. VGS-O. VG name LV count volume group name. Ensure the volume group does not contain logical volumes. VGS-O VG name, comma LV count space volume group name. So VGS-O VG name, comma LV count and the volume group name. Vol group say 200. Cannot process volume group LV count because there is no LV count here, there is no logical volume here. So VG name it is showing as volume group 200. Similarly for volume group 100, VGS hyphen or VG underscore name comma LV underscore count volume vol group 100. Replace volume group name with the name of the volume group. Remove the volume group. VG remove space volume group name. So to remove the volume group, VG remove space volume group name. VG remove space volume group name. So there are no logical volumes actually. So VG group space volume group name. So volume group 100. I'm making only 100 now. Volume group 100 successfully removed. Now VGS will show me only volume group 200. PVS will show me that there are 3 physical volumes are free now. 3 physical volumes are free. Removing LVM groups in a cluster environment. Removing LVM volume groups in a cluster environment. In a cluster environment, LVM uses the log space qualifier to coordinate access to volume group shared among multiple machines. You must stop the log space before removing a volume group to make sure no other node is trying to access or modify it during the removal process. So in a cluster environment, LVM uses the log space qualifier to coordinate access to volume groups shared among multiple machines. Coordinate access to volume groups. Volume groups are shared among multiple machines. You must stop the log space before removing a volume group. Before removing a volume group, use the stop the log space to make sure no other node is trying to access or modify during the removal process. To make sure no other node is trying to access or modify during the removal process. Prerequisites administrative access. The volume group contains no logical volumes. Procedure ensure the volume group does not contain logical volumes. The volume group does not contain logical volumes. VGS hyphen or VG underscore name comma LV underscore count volume group name. The volume group does not. The volume group contains no logical volumes. Ensure the volume group does not contain logical volumes. VGS hyphen or VG underscore name comma LV underscore count volume group name. VGS hyphen or VG underscore name comma LV underscore count volume group name. VGS hyphen O VG underscore name comma LV underscore count space volume group 200 volume group name. See, I don't have the logical volumes here, so it is not showing any logical volumes. Replace volume group name with the name of the volume group. Stop the log space on all nodes except the node where you are removing the volume group. Stop the log space on all nodes except the node where you are removing the volume group. So VG change hyphen hyphen log stop a volume group name. Replace volume group with the name of the volume group and wait for the log to stop. So VG change hyphen hyphen log stop. This is not in a cluster. VG change hyphen hyphen log stop volume group name. I will try the command volume group 200 using log stop start and log start requires LVM log D. So let me check the status. System CTL status LVM log D. So LVM log D could not be found. DNF what provides LVM log D. LVM log D RPM or package LVM2 log D. DNF install LVM2 log D. So it says this has an incorrect checksum. etc m dot repos dot rhel dot repo gp check. I'll disable the gp check. So etc m dot repos dot d. So I'll enable the gp check. Like looks like it is not mounted. Mount loop slash rhel on. Slash save slash mnt make directory hyphen p slash save slash mnt mount loop slash rhel on slash save slash mnt history dnf install lvm2 hyphen log d. So it is mnt disk red hat linux mount slash mnt So make directory -p slash mat slash this slash Red Hat Linux mount hyphen o loop RHL on slash mat slash this slash Red Hat Linux and a DNF install LVM2 hyphen log d. So install the package LVM2 hyphen log d. So that was slash save slash mat is improper. It should be slash mat slash this slash Red Hat Linux. Now try systemctl status history status log LVM log t. So systemctl start LVM log t systemctl status LVM log t. Now it is active history VG change hyphen log stop volume group 200. So still it is showing me the same, though it is present. LVM log t is still present. PS hyphen EF5 grep hyphen I. See, LVM log d is already present here. LVM log d started LVM log t. Okay, so this is the command VG change hyphen log stop volume group name. Replace volume group name with the name of the volume group and wait for the log to stop. Remove the volume group. VG remove volume group name. Removing the volume group. So VGS. So since I have only one volume group, I will not remove this volume group. Replace volume group name with the name of the volume group. VG remove and VG change. So basic logical volume management in LVM you can do the following task: create new logical volumes to extend storage capabilities of your system, extend existing volumes and thin pools to accommodate growing data, create new logical volumes to extend storage capabilities of your system, create new logical volumes to extend store. So I'm going to create new logical volumes to extend storage capabilities of your system, extend existing volumes and thin pools to accommodate growing data. So extend the existing volumes and thin pools, existing volumes and thin pools to accommodate growing data and thin pools. So extend existing volumes and thin pools to accommodate growing data. How do you accommodate growing data? Extend existing volumes and thin pools to accommodate growing data. Rename volumes for better organization. Rename volumes for better organization. Reduce volumes to free up unused space. Safely remove volume groups. So reduce volumes to free up unused space. Reduce volumes to free up unused space. Safely remove volumes when they are no longer needed. Safely remove volumes when they are no longer needed. Activate or deactivate volumes to control the system's access to its data. Activate or deactivate volumes to control the system's access to its data. Overview of logical volume features. Overview of logical volume features. With the logical volume LVM, logical volume manager LVM, you can manage this storage in a flexible and efficient way. You can manage this storage in a flexible and efficient way that traditional partitioning schemes cannot offer. Below is a summary of key LVM features that are used for storage management and optimization. You can manage this storage in a flexible and efficient way that traditional partitioning schemes cannot offer. Below is a summary of key LVM features that are used for storage management and optimization. Concatenation. Concatenation involves combining space from one or more physical volumes into a singular logical volume, effectively merging the physical storage. Concatenation involves combining space from one or more physical volumes into a singular logical volume, effectively merging the physical storage. Striping optimizes data input or output efficiency by distributing data across multiple physical volumes. This method enhances performance for sequential reads and writes by allowing parallel input or output operations. Striping optimizes data input or output efficiency by distributing data across multiple physical volumes. This method enhances performance for sequential reads and writes by allowing parallel input or output operations. This method enhances performance for sequential reads and writes by allowing parallel input or output operations. RAID. LVM supports RAID levels 0, 1, 4, 5, 6, and 10. So what are the RAID levels? 0, 1, 4, 5, 6, and 10. So 0, 1, 2, 3, LVM doesn't support 2 and 3. So 4, 5, 6, and 10. When you create a RAID logical volume, LVM creates a metadata subvolume that is one extent in size for every data or parity subvolume in the array. So when you create a RAID logical volume, logical volume, but it is a RAID logical volume. LVM creates a metadata subvolume. So LVM creates a metadata subvolume that is one extent in size. So one extent in size, metadata subvolume that is one extent in size for every data or parity subvolume in the array. For every data or parity subvolume in the array. So for every data or parity subvolume in the array, so there is already a subvolume which is a data subvolume or a parity subvolume. For every data or parity subvolume in the array, LVM creates a metadata subvolume that is one extent in size. So when you create a RAID logical volume, thin provisioning. Thin provisioning enables the creation of logical volumes that are larger than the available physical storage. Within provisioning, the system dynamically allocates storage based on actual usage of instead of allocating a predetermined amount upfront. Snapshots. With LVM snapshots, you can create point-in-time copies of logical volumes. The snapshot starts empty as changes occur on the original logical volume. The snapshot captures the pre-change states through copy on write COW, growing only with changes to preserve the state of the original logical volume. As you can create point-in-time copies of logical volumes, a snapshot starts empty as changes occur on the original logical volume. The snapshot captures the pre-change states through copy and write COW, growing only with changes to preserve the state of the original logical volume. Caching. LVM supports the use of fast block devices such as SSC drives as write-back or write-through caches for larger, slower block devices. Users can create cache logical volumes to improve the performance of their existing logical volumes or create new cache logical volumes composed of a small and fast device coupled with a large and slow device. Creating logical volumes. LVM provides a flexible approach to handling this storage by abstracting the physical layer into logical volumes that can be created and adjusted based on your needs. Creating a linear thick logical volume with linear logical volumes LVs. You can merge multiple physical storage units into one virtual storage space. You can easily expand or reduce linear LVs to accommodate the data requirements, prerequisites. Administrative access. The LVM2 package is installed. The volume group is created. For more information, see creating LVM volume group. List the names of volume groups and their sizes. VGS-O, VG underscore name, comma, VG underscore size. VGS-O, VG underscore name, comma, VG underscore size. So there should not be any space here in between VG comma and VG underscore size. So the current existing volume group is volume group 200 and the volume group size is 25 GB. Create a linear LV. LV create hyphen name, logical volume name, hyphen size, volume group name. Replace logical volume name with the name of the LV. Replace volume size with the size for the LV. If no size suffix is provided, the command defaults to MB. If no size suffix is provided, the command defaults to MB. Replace volume group name with the name of the volume group. Replace logical volume name with the name of the LV. Replace volume size with the size for the LV. If no size suffix is provided, the command defaults to MB. Replace volume group name with the name of the volume group. Verification. Verify that the linear LV is created. LVS-O, LV underscore name, comma, SCG underscore type. LV type logical volume name linear. So logical volume name, we have given the name as linear. So I'm going to create this linear logical volume with size. Size is not provided. I will provide my own size. So LV create. LV create hyphen name. Name is linear. Logical volume name is linear. Or I will provide my own name. Logical volume 1. Name is logical volume 1. Size. Volume size. The size of the volume group is size of the logical volume. I'm going to give it as 1 GB. Volume group name. Vol group 200. So logical volume log vol 1 created. LV create hyphen name is log vol 1 hyphen size is 1G vol group 200. Type the LVS command. LVS command gives the information about the logical volumes. So LV name of the LV is log vol 1. It belongs to the volume group vol group 200 ATTR. These are the attributes. Logical volume size is 1 GB. Pool origin data percentage, meta percentage, move, log, CPY percentage, sync, convert. So this is the data about the logical volume LVS. Verify that the linear logical volume is created LVS-O, LV underscore name, comma, SCG underscore type, segment type. LVS-O, LV underscore name, comma, there is no space after comma, segment underscore type. So type is a linear logical volume. So segment type, it's a linear logical volume. So segment type is, it is a linear logical volume. Name of the logical volume is logval1. LV name is logval1. Type is linear. Additional resources VGS, LVS, LV create packages. Creating or resizing a logical volume by using the storage RHL system role. Creating or resizing a logical volume by using the storage RHL system role. Use the storage role to perform the following tasks. Create an LVM logical volume in a volume group consisting of many Ds. To create an LVM logical volume in a volume group consisting of many Ds. To resize an existing file system on LVM. To express an LVM volume size in percentage of the pool's total size. Express an LVM volume size in percentage of the pool's total size. If the volume group does not exist, the role creates it. If a logical volume exists in the volume group, it is resized if the size does not match what is specified in the playbook. If you are reducing a logical volume, to prevent data loss, you must ensure that the file system on that logical volume is not using the space in the logical volume that is being reduced. This is very critical information. If you are reducing a logical volume, if you are reducing a logical volume, to prevent data loss, you must ensure that the file system on that logical volume is not using the space in the logical volume that is being reduced. Prerequisites: you have prepared the control node and the managed nodes. You are logged into the control node as a user who can run playbooks on the managed nodes. The account you use to connect to the managed nodes has sudo permissions on them. Create a playbook file, for example, /playbook.yml with the following contents. So let us create the playbook. --hyphen space name colon manage local storage. So name of the playbook is manage local storage. Host colon manage node 01.example.com task colon hyphen space name colon create logical volume. Ansible dot built-in dot include underscore role colon name colon redact dot rhl underscore system underscore roles dot storage vrs colon storage underscore pools colon hyphen space name colon space myvg disk colon hyphen space sta stp stc volumes colon. So this under this hyphen sta stp stc volumes colon under volumes hyphen name colon mylv and size colon 2g fs underscore type colon ext4 mount underscore point colon slash mnt slash data. The settings specified in the example playbook include the following. Size. In angular bracket size, you must specify the size by units. For example, GIB or percentage, for example, 60%. For details about all variables used in the playbook, see the USR share Ansible roles rhl-system-roles.storage/readme.md file on the control node. Validate the playbook syntax. So let me create the playbook. So change directory to playbook. Vi creating this playbook playbook.yml. Playbook2.yml triple hyphen space name colon manage local storage. Manage local storage host colon server.example.com, or I will give the same managed hyphen node hyphen 01 hyphen 01 dot example dot com task colon hyphen space name colon. So what is the name of the task? Name of the task is create logical volume. Create logical volume. Ansible dot built-in dot include underscore role colon. Ansible Ansible dot built-in built-in dot include underscore role colon. Ansible dot built-in dot include underscore role colon name colon. So name of the built-in role. So name should be name colon name of the built-in role. Redhat dot RHEL system roles dot storage. Redhat dot RHEL underscore system underscore roles. Redhat dot RHEL underscore system underscore roles. Redhat dot RHEL underscore system underscore roles dot storage. VARS variables. Declaring the variables. Variables colon storage underscore pools colon storage pools colon and name of the storage pools hyphen space name colon myvg hyphen space name colon space myvg disk colon. So name is myvg my volume group disk colon. What are the disks in it? STA, STB, STC. Hyphen space SDA hyphen STB hyphen STC. Volumes colon hyphen space name colon my LV volumes hyphen space name colon my LV volumes hyphen space name colon my LV size is 2G size is 2G fs underscore type name is my LV size is 2G fs underscore type ext4 ext4 mount underscore point mount point is slash mnt slash data. Save this file. The settings specified in the example playbook include the following size colon and angular bracket size. You must specify the size by using units, for example GB bytes, or percentage, for example 60%. For more details about all variables used in the playbook, see the USR share Ansible roles rhl-system-roles.storage/readme.md file on the control node. Let me check this file. USR share Ansible roles. USR Ansible roles RHL-system RHL system roles storage slash readme.md file. RHL system roles dot storage readme.md file. This role allows users to configure local storage with minimal input. This role, Linux storage role, this role allows users to configure local storage with minimal input. As of now, the role supports managing file systems and mount entries on disk. LVM volume group Stratis polls with Stratis v3 and newer. Encryption using Lux and RAID using MD is also supported. Support for managing pre-existing devices is limited, but new LVM volumes and Stratis file systems can be added to existing setups and mount points, and some other features can be added to or removed from existing devices. Requirements and role variables. Storage underscore pools name type state grow to fill shade this RAID level volume encryption volumes encryption password encryption cipher encryption key size encryption Lux version encryption clevis pin encryption tag URL encryption tag thumbprint storage volume state disk size FS type FS label mount point mount options mount user mount group mount mode RAID level RAID device count RAID spare count RAID metadata version RAID chunk size RAID type size RAID disk encryption underscore password encryption underscore key encryption underscore size encryption key size encryption Lux version deduplication compression video pool size cache size cache underscore mode cache underscore devices thin pool name thin pool size storage safe mode storage udev trigger playbook. So playbook a triple backout YAML hyphen space name colon manage storage host colon all. So this is an example playbook. Host colon all roles colon hyphen space name colon RHL hyphen system hyphen roles dot storage storage underscore polls colon hyphen space name colon app this colon hyphen space stb hyphen space stc volumes colon hyphen space name colon shared size colon double quote 100 gab mount point colon double quote mnt app shared fs underscore type colon xfs state colon present in hash hyphen space name colon users size colon 400 G double quote fs type colon ext for mount point mnt app user storage volumes name images type disk colon mpath c mount point opt images fs underscore label colon images showing the host as all syntax check. So validate the playbook syntax ansible hyphen playbook hyphen syntax hyphen check playbook.yml. I'm just checking the syntax ansible hyphen playbook hyphen syntax hyphen check playbook2.yml playbook underscore 2. This warning host list is empty. So syntax, there is some problem with the syntax because all the parameters are not available here. Provided host list is empty, only localhost is available. Manager note that the implicit localhost does not match all. Note that this command only validates the syntax and does not protect against a wrong but valid configuration. This command only validates the syntax and does not protect against a wrong but valid configuration. Run the playbook ansible hyphen playbook tilde slash playbook.yml verification. Note that the Ansible managed node has been created or resized to the requested size. So if there is node is available, managed node 0-01.example.com and I run this Ansible playbook, then the specified volume will be created or resized to the requested size. Specified volume will be created. The specified volume will be created and resized. Resize specified volume will be created and resized to the created or resized to the requested size. Ansible managed node 01.example.com -m the command -a single quote lbs myvg -m command -a single quote lbs myvg my volume group. Additional resources USR share Ansible roles RHL system roles dot storage slash readme.md file USR share doc RHL system role slash storage directory. So I'll check this directory USR share doc ls slash USR slash share slash doc slash RHL system roles. RHL system roles slash storage. So here there is readme.md file, changelog.md file and readme.html file. Creating a striped logical volume. With striped logical volume LV, you can distribute the data across multiple physical volumes PVs, potentially increasing the read and write speed by utilizing the bandwidth of multiple disks simultaneously. When creating a striped LV, it is important to consider the stripe number and size. The stripe number is the count of PVs across which data is distributed. Increasing the stripe number can enhance performance by utilizing multiple disks concurrently. Stripe size is the size of the data chunk returned to each disk in the stripe set before moving to the next disk and is specified in kilobytes. The optimal stripe size depends on your workload and the file system block size. The default is 64 KB and can be adjusted. Prerequisites: administrative access. Procedure: list the names of volume groups and their sizes. VGS-O VG underscore name, VG underscore size. VGS-O VG underscore name, VG underscore size. Volume group, be a vol group 200. VG, V size is 25G. Create a striped LV. LV create hyphen stripes. Number of stripes hyphen stripe size. Stripe size hyphen size. Logical volume size hyphen name. Logical volume name. Volume group name. Replace number of stripes with the number of stripes. This one. Number of stripes with the number of stripes. Replace stripe size with the stripe size in kilobytes. Replace stripe size with the stripe size in kilobytes. Stripe size in kilobytes. Hyphen stripe size is not a required option. Hyphen stripe size is not a required option. If you do not specify the stripe size, it defaults to 64 KB. If you do not specify the stripe size, it defaults 64 KB. Replace logical volume name. Logical volume name with the name of the logical volume. Logical volume name with the name of the LV. Replace volume group name with the name of the volume group. Replace volume group name with the name of the volume group. Verification. Verify that the striped LV is created. Verify that the striped LV is created. LVS hyphen LV underscore name, SCG underscore type. So LV create. LV create hyphen stripes. LV create hyphen stripes. Number of stripes. Number of stripes. I'm giving 2. What does number of stripes mean? Number of stripes means the stripe number. What is stripe number? Stripe number is the count of PVs across which data is distributed. The count of physical volumes across which data is distributed. So how many physical volumes I have? VG scan, PV scan. I have 2 physical volumes in the volume group 200. So I'll give the stripe size as 2. I'll give the stripe size as 2. Number of physical volumes. LV create hyphen stripes. LV create hyphen stripes. Number of stripes is 2. Hyphen stripe size is stripe size default is 64 KB. So I will omit the 64 KB stripe size here because the stripe size is default is 64 KB. Hyphen size, logical volume size. What is the size of the logical volume that we created? For this I need to again type LVS. Size is 1 GB. So LV create stripes is 2. Size, logical volume size is 1 GB. Hyphen name. Name is logical volume name. Logical volume name is log vol 1. Logical volume name is log vol 1. Volume group name. Volume group name is vol group. Volume group 200. LV create hyphen stripes is 2 stripes. Stripe size I omitted because the default stripe size is 64 KB. I'll use the default stripe size. Hyphen size is logical volume size, so I'm giving 1 GB. Hyphen name, logical volume name, log vol 1, and volume group name, vol group 200. So the LV already exists. So logical volume 1 already exists here. So I'm giving a different name for the logical volume. Log vol stripe 1. So logical volume log vol stripe 1 created in the volume group. Which volume group? 200. I've created the logical volume log vol stripe 1. LVS. So log vol stripe 1 created in the volume group 200. LV scan. So all the volume groups are active. VGS. So VGS now has 2 logical volumes here, 2 physical volumes and 2 logical volumes. VG scan, and similarly PVS and PV scan. Verify that the striped LV is created. Verify that the striped LV is created. Use the command lvs-o lv underscore name comma scg underscore type. lvs-o lv underscore name lv name comma scg underscore type. So you can see that log vol stripe 1 is a striped logical volume. Log wall type 1 is a striped logical volume. The segment type is striped. Log wall 1 is linear. Log wall type 1 is striped. LVS icon LV underscore name, SEG underscore type. Additional resources the VGS, LVS and LV create man pages. Creating a RAID logical volume. RAID logical volumes enable to use multiple disks for redundancy in performance. LVM supports various RAID levels including RAID 0, RAID 1, RAID 4, RAID 5, RAID 6 and RAID 10. With LVM you can create striped RAIDs, RAID 0, RAID 4, RAID 5 and RAID 6, mirrored RAID, RAID 1 or a combination of both RAID 10. So what are the striped RAIDs? RAID 0, 4, 5 and 6 are striped RAIDs. Mirrored RAID is RAID 1 and a combination of both is RAID 10. RAID 4, 5 and 6 offer fault tolerance by storing parity data that can be used to reconstruct lost information in case of a disk failure. So 4, 5 and 6 offer fault tolerance by storing parity data that can be used to reconstruct lost information in case of a disk failure. When creating RAID LVs, place each stripe on a separate PV. When creating RAID LVs, place each stripe on a separate PV. The number of stripes equals to the number of PVs that should be used in the volume group VG. The number of stripes equals to the number of PVs that should be used in the volume group VG. Minimal RAID configuration requirements: RAID level type, parity, minimum number of devices, minimum stripe number. RAID 0 striping, parity none, minimum number of devices are 2, minimum stripe number is also 2. RAID 1 mirroring, parity is none, minimum number of devices are 2, minimum stripe number is not applicable. RAID 4 striping, uses first device to store parity, minimum number of devices are 3, minimum stripe number is 2. RAID 5 striping, uses an extra device to store parity, minimum number of devices are 3 and minimum stripe number is 2. RAID 6 striping uses 2 extra devices to store parity, minimum number of devices are 5 and minimum stripe number is 3. RAID 10 striping and mirroring, use none, no parity, so minimum number of devices are 4 and minimum stripe number is 2. Prerequisites: administrative access. List the names of volume groups and their sizes. VGS -O, VG underscore name, VG underscore size. VGS -O, VG underscore name, VG underscore size. VGS -O, VG underscore name, VG underscore size. Create a RAID logical volume. To create a RAID, striped RAID, use LV create -, type RAID level -, stripes, number of stripes -, stripe size, stripe size -, size is size -, name, logical volume name, volume group name. Replace level with RAID level 0, 4, 5 or 6. Replace number of stripes with the number of stripes. So replace level RAIDs, replace level with the RAID level for 0, 4, 5 or 6. Replace number of stripes with the number of stripes. Replace number of stripes with the number of stripes. Replace stripe size with the stripe size in kilobytes. Replace stripe size. Replace stripe size with the stripe size in kilobytes. Stripe size in kilobytes. stripe size in kilobytes, replace size with the size of the LB. Replace size with the size of the LB. Replace logical volume name with the name of the LB. Replace logical volume name with the name of the LB. To create a mirrored RAID, use LB create hyphen type RAID 1 hyphen mirrors number hyphen size and size hyphen name logical volume group name. Replace mirrors number with the number of mirrors. Replace size with the size of the logical volume. Replace logical volume name with the name of the logical volume LB. To create a mirrored and striped RAID, use LB create hyphen type RAID 10 hyphen mirrors number hyphen stripes number of stripes hyphen stripe size hyphen size is size hyphen name logical volume name volume group name. Replace mirrors number with the number of mirrors. Replace number of stripes with the number of stripes. Replace stripe size with the stripe size in kilobytes. Replace size with the size of the LB. Replace logical volume name with the name of the LB. Replace logical volume name with the name of the LB. So I'm going to create these logical volumes. So create a RAID LB. To create a striped RAID, use LB create. LB create hyphen type. Type is RAID level. So striped RAIDs, mirrored RAIDs, mirror and striped. Striped RAIDs are 0, 4, 5 and 6. So RAID 0. RAID 0 space hyphen stripes. Stripe space number of stripes. For RAID 0, what is the number of stripes? Number of stripes is 2. Number of stripes is 2 for RAID 0. So I'll put 2 here. Before this, I will add more physical volumes into the volume group. I will add more physical volumes into the volume group. BG extend volume group and the name of the physical volume. BG extend volume group, name of the physical volume slash save slash STE slash save slash SDF and slash save slash SDH. Volume group, vol group 200 successfully extended. PV scan, VGS, what is the maximum number of physical volumes that I will require for the stripes? Minimum number of this. Minimum number of these up to 5. I may require up to 5. Do I have up to 5? I have up to 5 physical volumes also. Minimum number of stripes. Minimum number of stripes maximum is 3. So I'm creating RAID level 0. LV create hyphen type RAID 0. Type is RAID 0. hyphen stripes. Number of stripes. Number of stripes are 2. Hyphen stripe size. Stripe size. Stripe size. What is the stripe size for 80? Stripe size is 64 KB. So I will omit the stripe size, or I will give 64 KB. Let me try 64 KB. 64 KB. Stripe size. Kilobyte. 64 KB. Hyphen size is size. Hyphen size is size 1 GB. I'm giving the size as 1 GB. Hyphen name. Name of the logical volume. Logical volume name. I'm giving the logical volume name as log vol rate 0. Logical volume rate 0. And volume group name. Volume group name is vol group 200. I can put a backslash to continue to the next line. Vol group 200. So LB create hyphen type is write 0. Hyphen stripes is 2. Stripe size 64 KB. Size is 1 GB. Name is log vol rate 0. Log volume group name. No command which matching syntax recognized. LV create hyphen type raid 0. Stripes. Hyphen stripes is 2. Hyphen stripe size. Stripe size space. Stripe size is 64 KB. Hyphen size. The size is 1 GB byte. Hyphen name is log vol rate 0. Logical volume rate 0. Volume group name. So it created logical volume rate 0. I gave a backslash, it did take here. So I created rate 0, logical volume rate 0. LV scan. See, rate 0 is active right now. Slash save slash vol group 200 slash log vol 0. Logical volume 0, rate 0 is active. Similarly, I've created the stripe trade 4, 5 and 6. LV create hyphen hyphen type is raid 4 stripe trades hyphen hyphen stripes. For raid 4 it is 3 stripes, 3 stripes, sorry 2 stripes, raid 4 it is 2 stripes, 2 stripes, raid 4 it is 2 stripes, raid 4, stripe size 64 KB, hyphen hyphen size is 1 GB, name is log wall raid 4, log wall raid 4, 0, 4, 5 and 6, 0, 4, 5 and 6, log wall raid 4. So I need to see the table and provide the stripe size, stripes, number of stripes and the raid level. Wall group 200, volume logical volume group name. So logical volume log wall raid 4 created. Type 4 is raid 4. Similarly, LV create hyphen hyphen type now raid 5 hyphen hyphen stripes. Raid 5 also 2 stripes. Stripe size 64 KB. Hyphen hyphen size is 1 JB byte. Hyphen hyphen name log wall raid 5. Volume group is 200. So logical volume raid 5 created. LV create hyphen hyphen. Type is raid 6 now. Stripes. So number of stripes. Stripes is 3. Stripe size 64 KB. Size is 1 GIP. Hyphen name is logical volume raid 6. Volume group is 200. LV create hyphen hyphen type is raid 6 hyphen hyphen stripes is 3. Stripe size is 64 KB hyphen hyphen size is 1 GB 1 GIB. Name is logical volume raid 6. Volume group 200. So logical volume raid 6 created. So LBS, BGS, so still 39.26 GB is free in the volume group. And volume group size is 46.98 GB. All the logical volumes have created log wall 1, RAID 0, RAID 4, RAID 5, RAID 6. Have created all the volume groups. sorry, logical rates. To create a mirrored rate use LV create hyphen type is RAID 1. To create a mirrored rate use LV create hyphen type is RAID 1. Mirror space mirrors number space size space namespace logical volume group name. Replace mirrors number with the number of mirrors. Replace mirrors number with the number of mirrors. Replace size with the size of the LB. Replace size with the size of the LB. Replace logical volume name with the name of the LB. Replace logical volume name with the name of the LB. So I'm creating RAID 1. LV create hyphen type is RAID 1. Hyphen mirrors. Mirror space mirrors number. Here mirrors number is RAID 1, it is 2. Number of mirrors means minimum number of devices, it is 2. Mirror space 2. Mirrors number is 2 and size hyphen size. Size is 1 GB byte. I'm giving 1 GB byte. Hyphen name. Logical volume name. Log vol RAID 1. Volume group name. Vol group 200. Log vol RAID 1. LV create hyphen type is RAID 1. Hyphen mirrors is 2. Hyphen size is 1 GB byte. Hyphen name is log vol RAID 1. Volume group is 200. So name is logical volume name log vol RAID 1. Volume group name vol group 200. So logical volume log vol RAID 1 created. LV scan. Replace mirrors number with the number of mirrors. Replace size with the size of the LV. Replace logical volume name with the name of the LV. Replace logical volume name with the name of the LV. To create a mirrored and striped ride. To create a mirrored and striped ride use LV create hyphen type ride 10 mirrors number stripe space number of stripes stripe size space stripe size size space size name logical volume group name. LV create type is ride 10 mirrors space mirrors number for ride 10 mirrors number is 4 ride 10 it is 4 4. Mirrors number is 4. Hyphen hyphen stripe space number of stripes. Number of stripes. Number of stripes is for rate 10. Number of stripes is 2. Hyphen hyphen size. Hyphen hyphen stripe size. Stripe size is the stripe size I am giving as 64 kilobytes. This is the default size. Hyphen hyphen size. Size of the logical volume. Logical volume giving 1 GB bytes. Hyphen hyphen name. Name of the logical volume. Log wall RAID 10. Logical volume. Log wall logical volume name. Log wall RAID 10 and volume group name. Volume group name is volume group 200. Vol group 200. RAID 10 currently supports only two-way mirroring. Hyphen hyphen M is okay 4. I have given 4 here. So it's RAID 10 currently supports only two-way mirroring, it says. So we are reducing the number of mirrors to 2. So it says only one mirror. Not even two mirrors, only one mirror. Insufficient suitable allocatable extents for logical volume log wall RAID 10. 204 more required. So reducing the size here. Instead of 1 GAP, I'll give 500 KB. So RAID 10, I've created RAID 10. LV create hyphen hyphen type is RAID 10. Mirrors is 1. Stripes is 2. Stripe size is 64 KB. Size is 500 KB. Hyphen hyphen name is log wall RAID 10. Volume group 200. So rounding up size to full physical extent 4 MIB. Rounding size 4 MIB. 4 MIB 1 extends up to stripes boundary size 8 MIB 2 extends. Logical volume log wall RAID 10 created. So verify that the RAID LV is created. LVS hyphen o LV underscore name comma SCG underscore type. LVS hyphen O, LV underscore name, segment underscore type. So you can see the type is also mentioned here. Logical volume rate 0. Log wall rate 0 is rate 0. Log wall rate 1 is rate 1. Log wall rate 10 is 10. Log wall rate 4 is rate 4. Log wall rate 5 is rate 5. Log wall rate 6 is rate 6. Log wall stripe 1 is stripe. Log wall 1 is linear.